Okay, got page 471, number 18. And it's finding the integral of, from negative infinity of x squared e to the x dx. Okay, so we're going to take the limit. So I'm going to replace this negative infinity with a b or an a, whatever. I already wrote b, so I'll write b. As b goes to negative infinity until 0 of x squared e to the x. Okay, so to integrate x squared e to the x, you need to do integration by parts, which we call ultraviolet voodoo to help you remember. And then when it's this type of one of the guys, the x squared, is an algebraic. If you keep on taking its derivative, it'll get to 0. And then the other function, e to the x, is one that loops around and become, antiderivative of e to the x is still e to the x. It just keeps repeating. We can do tabular, which is much faster. So it's x squared, the one that goes down to 0, I'm going to take the derivatives of, right? So x squared and then 2x and then 2 and then 0. E to the x, remember, you're doing antiderivative, which not that it matters with e to the x because it's e to the x and e to the x and e to the x. And then multiply down the diagonal with a positive, and then the next diagonal you'll subtract, and then the next diagonal you'll add. So that this becomes the limit as b goes to negative infinity of, it'll be an x squared e to the x, and then a minus 2x e to the x, and then a plus 2e to the x, and from b to 0. So now I'll plug these values in, and I would have plugging in a 0 will give me a 0 squared e to the 0, which is just 0, minus 2 times 0, e to the 0, which is also just 0. But then this guy is not. 2 times e to the 0 will just be a 2. And then we're going to subtract from that, doing b squared e to the b minus 2b e to the b, and plus 2 times e to the b. That. And so this guy, that's a 0, that's a 0. This ends up being 2. That's a 2. What's happening with these guys, though? Oof. You got an infinity times e to the negative infinity, which is 0. Okay, so technically, what you really need to be doing is these guys, well, this guy, that last term zeroes out. But these guys, you really should be doing L'Hopital's, right? Because you've got an infinity times 0. Okay, so let me go to the next page real quick. Well, no, let me do this. Okay, I'm gonna take each of these one at a time. The limit as b goes to negative infinity of b squared e to the b would really be negative infinity squared would be a positive infinity. This is an infinity times e to the negative infinity, which would be a 0. I really just want to cheat and say, an e to an infinity is going to go much faster than a b squared. Like, so the e to the b overpowers it, but whatever. I'll just do this as L'Hopital's, right? So this is the limit as b goes to negative infinity of, how about, which way would make sense if I go, e to the b divided by b to the negative 2, right? All I did was set it to divide so that now it's negative infinity, so that's an infinity over and then 0. Yeah, and so taking the derivative of this, now doing L'Hopital's rule, this question is, okay, I'm not a fan, but whatever. Okay, so it's derivative of e to the b would be e to the b. B is your variable, so times the derivative of b would just be 1. And then over negative 2b to the net. Is that helping at all? No, it's not. So maybe I shouldn't have done it that way. Let's see if there's a better way for me to show it to you. I feel like, was there one like that on the quiz? Yes, there was. Okay, that would be helpful. Okay, so there was one, is it exactly the same one? It's not exactly the same one, but it's very similar to the one on the quiz. That's exactly what you want to do, is you want to factor out e to the b. Okay, so I'm going to rewrite this sentence or that statement on the next page. So right now I've got, oh crap, take a picture of it so I remember what to write on the next page. Oh, okay. All right, so I've got the limit as b goes to negative infinity of, and it ended up being a 2 and then a minus the b squared e to the b minus 2b e to the b plus 2 e to the b. Okay. And so what I'm going to do is factor out the e to the b, and then you're left with a b squared minus 2b plus 2, like that. And we're taking this as the limit as b goes to negative infinity. So that does end up being, for this part right here, it ends up being 0 times b squared infinity plus another infinity. So it ends up being 0 times infinity, right? So this guy ends up being, if I take the limit as b goes to negative infinity of, I'll write it as b squared minus 2b plus 2. That's where my mistake was. I should have stuck the e to the down to the bottom. Divided by e to the negative b. And then that ends up being an infinity over e to the positive infinity will now be an infinity. So you got an infinity over infinity. And then now I can do L'Hopital's rule and do, this is the limit as b goes to negative infinity of, it's a 2b minus 2 over a negative e to the negative b, which is still a negative infinity over infinity, negative infinity, because that would be a positive, yeah. So that's still an infinity over infinity. So we'll do L'Hopital's again, and that'll give you a 2 over positive e to the negative b. Now when you plug that negative infinity in, it ends up being a 2 on top, so not a problem, and then it'll be an e to the negative of a negative, so positive infinity, and so it ends up being a 2 over infinity, which is 0. Whew. All right, so all of that for that guy, so that now when we bring this down here, that means that the limit as b goes to negative infinity of, you end up with a 2 minus 0, which ends up being just 2. Is that the right answer? Hopefully. What number was this? 14, number 18. Yeah, 2. It was on the quiz like that. I think we do have one that's kind of sort of weird like that on the test too. So that was a good question. Number 14 on, no, number 4 on the worksheet. And thanks for reminding me about factoring out the E to the B. That's the trick on that one. Okay, number 4 is a very good question on tonight's homework worksheet, number 4. It wants to know if the limit converges or diverges. So here's what I know. This -1 to the nth power makes it alternate in sign, right? But not all oscillating sequences diverge, right? Sometimes they do and sometimes they don't. You might see one where, you know, you could go and be from here and then up here and then down here and then up there and then like this one is getting bigger and bigger and bigger, and one like this would absolutely diverge. But you could also see one that maybe starts up here and then over here and then here and then here and then here and then here and it's getting closer and closer and closer and closer to 0. And this one would converge even though it's alternating in sign. Yes? So it has to do, just because it alternates does not mean that it diverges. What you have to look at is, does this part go to 0 or converge to 0? And the trick to that is, if I take the limit as n goes to infinity, we did these back last semester, right? If I divide top and bottom by n is really the easiest way to get this done. The limit as n goes to infinity of, it's a 1 minus 5 over n over 1 plus 1 over n. And as n goes to infinity, 5 over n zeroes out, and so does 1 over n. And so you end up with just 1 over 1, and so this goes to 1. So basically, as n goes to infinity, this guy ends up being something like, you could also, here's the other deal, you could just start plugging numbers in, right? And when you plug a 1 in, you know, you could find the terms. So what would a 1 be? 1 would be 5. Okay, so you start off with 5. And then the next one is going to be a negative value. 2 would be what? -3. Anyway, and then, but it's alternating, but it keeps, you know, going up and down like that because because that second term is not going to a 1. And so that means that it's definitely oscillating and it's diverging because the other terms are not going to 0. Another way to say, maybe it'll be helpful to like start expanding these out. This sequence, I'm going to go to a different page. This sequence, and maybe this is really how I should have started it, was maybe I should have started listing out the terms of the sequence just to get an idea of what's happening. So on the first term, so A1 would be -1 to the power of 1 over 1 minus 5 over 1. Okay, I was way off on my estimation. On my graph when I tried to graph this thing. So that's a negative of, what is that? -4 over 2. So it's a 2 on the first term. And then the second term would be a -1 squared 2 minus 5 over 2 plus 1. We're going to revisit all of these next chapter also, by the way. So just, anyway, that's a +1. And then a -3 over 3. So you end up with a -1. And then the third term is a -1 cubed. and it's a 3 minus 5 over 3 plus 1, which ends up giving you a negative and then a, what is that? Negative 2 over 4, so it's definitely not obvious right now, but it's positive, and it's a positive 1/2. And then the fourth term, so maybe this wasn't super helpful. 4 minus 5 over 4 plus 1 gives you a positive and a negative 1/5. Oh, shit. At some point, it should kind of level off, and you're just getting closer and closer to 1. Well, no, negative 1, positive, like it just keeps going back and forth. What is that? A 5, oh, that'll be helpful. 5 minus 5 over 5 plus 1, that ends up giving you a 0. What does the sixth one do? 5. It was a negative 0, so to the 6th power, so that's a positive, and then 6 minus 5 over 6 plus 1, which will give you a positive, and then a 1 over 7. Anyway, the point is that this kind of looks like it's getting smaller, but it doesn't, because n minus 5 over n plus 1 just goes to 1. So yeah, I guess this wasn't helpful. Ignore, whatever. Most times, though, you can start plugging things in, kind of get an idea, but really it comes down to doing the limits. So, all right, 11 on the quiz. Ugh, I just did one exactly like it. So it's done exactly like the one I just did, except it's worse. So I guess I can do it if you really want me to. Number, the answers on the answer, it says D, which says oscillating. For number 4, I said it diverged. It diverges. It doesn't, my worksheet says diverges, not oscillating. It does oscillate, that is true, but yeah, because this guy goes to 1, and then you're at negative 1 to a power, and so it just keeps on going back and forth, and it's not going to 0 as n goes to infinity. Okay, good. Yeah, so definitely, but just keep this in mind. I wrote alternate here. It's the same thing as oscillating. But just because something oscillates does not mean that it diverges. You've got to look at this second term right here. Because if that guy goes to 0, then it converges to whatever that to 0, right? But even if it's bouncing back and forth between positives and negatives. So you're going to learn, again, you're going to learn more about that in chapter 10 with when we do sequences and series and stuff. Okay. What am I doing? Oh yeah, you wanted me to do this stupid quiz number 11. All right, well, I'll do it. All right, so it's done almost identical to the one I just did. The only difference is this is a e to the 3x instead of just an x. And so I'm going to write it as this is the limit as b goes to negative infinity of, I'm going to change this to a b, and then x squared and e to the 3x dx. And then again, integration by parts because it's two things being multiplied in there. And remember, when you take the derivative of two things being multiplied, you'd have to do product rule. So it's integration by parts, but since one of these guys goes to 0 and the other guy loop-de-loops, then we can do tabular. So it would be an x squared, and then a 2x, and then a 2, and then a 0. Remember, you take the derivative, so on that one. But on e to the 3x, you're doing antiderivatives. So antiderivatives of this would be e to the 3x, but you would have to undo the 3. So it would be a 1/3 e to the 3x. And then same thing again, you got to undo the multiplying by 3 because of the chain rule. So that would be a 1/3 times 1/3, so a 1/9. And then on this one, c to the 3x again, but you'd have to undo the times 3. So it's a 1/27. And that's a plus, and a minus, and a plus. And so this ends up being the limit as b goes to negative infinity of 1/3 x squared e to the 3x minus 1, nope, I'm going to say 2/9 times x e to the 3x, and then a 2/27 e to the 3x. And they're going from b to 0. All right, so plugging in a 0 into there, you would have a 0 minus 0 plus 2/27 times e to the 0, so that's just a times 1, and then subtract from that, and I'm going to for sure run out of room, so I'm going to come, it's a subtract, and then plugging in b would be a 1/3 b squared e to the 3b minus 2/9b times e to the 3b, and then a plus 2/27 e to the 3b. Okay, so this part right here is the part that we've got to do L'Hopital on, right? This one ends up being a times a 1. So that part just ends up being 2/27. But this part here, let's factor out the e to the 3b, and I'd be left with a 1/3 b squared minus 2/9b, and then a plus 2/27. Yeah, and I'm taking the limit as b goes to negative infinity. And so what you want to do, this is a what was that, a 0 times infinity, because e to the negative 3 infinity will be a 0, but then the rest of this would be infinity. So I'm going to rewrite it. Before I can use L'Hopital's rule, I need to rewrite it so that it's a fraction over a fraction. I'm going to write it as 1/3 b squared minus 2/9b plus 2/27, and then divide it by e to the negative 3b now. Since dividing by a negative exponent, right, it ends up being positive like that. Okay, so I'm going to rewrite that on the next page. And then don't forget, we still have, well, I'll write it. So right now we've got the limit as b goes to negative infinity of, it was a 2/27 and then a minus all of this guy, which that whole part was, we're doing the limit as b goes to negative infinity of, it was 1/3 b squared minus 2/9b plus 2/27 all over e to the negative 3b. Okay, so that's what I just wrote on there. Now when you plug in a negative infinity, it would be infinity, a negative infinity squared would be a positive infinity minus a negative infinity, another positive, so this is a infinity over, when you plug in a negative infinity in here, it ends up being a negative of a negative, so it's positive infinity. So that means I can do L'Hopital's rule. Got the limit as b goes to negative infinity of, this would be a 2/3 b minus 2/9 plus 0. because I just took the derivative of the top. Derivative of the bottom would be a negative, or an e to the negative 3b, but then times the derivative of negative 3b, where b is my variable, so times negative 3. What does that give me? That still gives me a negative infinity over e to the, it'll be a positive infinity, so that is another technically negative infinity because of the negative out front. So it's still an infinity over infinity. So we're going to do L'Hopital's again, which will give you a 2/3. Yay. As soon as you get a constant on either the top or the bottom, you're like, thank the Lord, I don't have to do this again. And then derivative of the bottom would be an e to the negative 3b, but you would need to multiply by a negative 3, so it ends up being a positive 9. So now, when you plug in negative infinity, which I say plug in, technically we're not supposed to be plugging in, but you're really taking the limit as b goes to negative infinity, which means that it's 2/3 divided by a negative infinity. You could always picture what the graph looks like too, right? It's e to a negative is just y equals e to the negative whatever. The graph looks like this, and so the limit as x is going to negative infinity. Oh look, you're going to positive infinity. That's really what's happening, is you're just checking out what the graph looks like, right? But to be honest with you, I always cheat and I plug in a negative infinity into b, and a negative times a negative is a positive, and e to the positive infinity is infinity, and a number divided by infinity is 0. And so all of that ended up being 0, and so your final answer was, we had the limit as b goes to negative infinity of 2/27, and then minus, that whole thing was 0, and so your answer ends up being 2/27. Whew, that was crazy. Cray. Okay, so that was number 11 on the quiz. Hopefully y'all don't ask me to do another one like that, because I did 2 of them like that. Number 11 on the worksheet. Oh, yay. I'm so excited to do this one. Just kidding. You probably are going to see something like this, so it's good. Worksheet number 11. Do you want to know the limit as x goes to 0 from the right of tangent of x to the x? Do you see that it is a function of x, right? A function of x, and then raised to the power of x. That's when you need to use logarithms, right? You're going to do logarithmic differentiation, and then at the end our answer will be e to the whatever. So I'm going to let f of x, my function, be tangent of x to the power of x, so that now when I take the natural log of both sides, and I do that so that I can get that x out of the exponent, right? Because now I can take this x and go whoop, and put it in front there. So I've got the natural log of f of x is equal to x times the natural log of tangent of x. All right, so I'm going to look at this right side. I'm going to take the limit as x goes to 0 from the right of x times the natural log of tangent of x. And what is that? That ends up being a 0 times natural log graph looks like this. This is just the parent graph of y equals the natural log of x. And so you're looking at the natural log of tangent of x but as x goes to 0, tangent of 0 is 0. And so you're looking at what's the limit as x goes to 0 of the natural log of 0, right? And here's when x is 0. So it's a negative infinity. So you've got a 0 times negative infinity, which means that, right? Yeah, 0. Yeah. So what you're going to do is rewrite this guy. Rewrite it so that you can use L'Hopital's rule. So we're going to do the limit as x goes to 0 from the right of the natural log of the tangent of x, and then over 1 over x, since that's the same thing. And so now I've got technically a negative, from the right, a negative infinity over an infinity. So that means you can do L'Hopital's rule. Do L'Hopital's. Take the limit as x goes to 0. Derivative of the natural log is 1 over whatever that is. So 1 over tangent, taking the derivative of the natural log, but then times the derivative of the inside, because of chain rule. And the derivative of tangent is, right, we're going this way, so secant squared. And then over derivative of 1 over x would be a negative 1 over x squared. All right, so before I start plugging in any zeros and going cray-cray, I'm going to simplify this. You don't want fractions within fractions. You want to simplify the fractions and then try plugging in that limit, right? So I'm going to rewrite this on the next page. Do I have this written anywhere? Okay, yeah. Okay, so I'm going to rewrite it on the other page. We've got the limit as x goes to 0 from the right of, it was a 1 over tangent, and then times secant squared, and then all over negative 1 over x squared. Okay, so I'm going to rewrite this guy. Here's what I know. I know that tangent is sine over cosine. 1 over tangent is cotangent. So I could write this as cosine of x over sine of x. And then secant is 1 over cosine. So that's a 1 over cosine squared. And then I have a over, okay, I'm going to fix that in a minute. I'm going to kick that upstairs too. All right, so what does that mean? That means that my cosine on top here is going to cancel with one of the cosines on the bottom. And then dividing by a fraction means you're going to multiply by the reciprocal. So this becomes a limit as x goes to 0 from the right of a negative x squared over sine of x cosine of x. Yeah, that's some algebraic manipulation right there that we do expect you to know how to do. Multiplying by the reciprocal, right? All right, so can I plug in a 0 now? Well, let's see. I get a 0 on top, and then a sine of 0 is, damn it, 0. 0 times 1 is still 0. So you've got a 0 over 0. So that means you're going to do L'Hopital's again. And that means that it's the limit as x goes to 0 from the right. And then derivative of the top would be a negative 2x. Derivative of the bottom, you've got to do product rule. So if I take the derivative of sine, it's cosine of x times the second guy, and then plus sine of x, and then times the derivative of cosine of x is a negative sine of x. Oof. Okay, so let's simplify that. That's the limit as x goes to 0 of negative 2x over cosine squared minus sine squared. Can I plug 0 in now? I would have a 0 on top, and on bottom, cosine of 0 is 1, and sine of 0 is 0. So you have a 0 over 1, which means that it's 0. Yeah? So, don't forget though, right in the very beginning, we said that the natural log of f of x was equal to the limit and blah, blah, blah. So, is equal to 0. So, to find f of x, you're going to take e to both sides. So, e to the 0, your answer is 1. Right? What was that? Number 11. Yep. Oh, I forgot to identify that it was a 0 to a 0. Frickety frackater. Okay, let me go back over there real quick. Oh, whoops, I hit the wrong button. Back. Because you do have to identify what that original function is. Okay, so identify what's the indeterminate form. This is a tangent of 0 is 0, and then plugging in a 0 into x is a 0. So that's what you would say for the what's the indeterminate form. It would be a 0 to a 0 on this problem. So that is why it's A for your final answer. All right. Did I skip one? You're welcome. Factor 11. Okay, that was that one. Okay. Can you change cosine squared minus sine squared to an identity? Yes, you can, if you remember that. But you're doing work that you didn't really need to do. But by all means, if you remember that this guy is cosine of 2x, right? You can replace that. It's equivalent. Take that limit as x goes to 0, which means that it's just cosine of 0, which is 1, which is what I said that the denominator was. The fact that, those guys are the same. They better be the same. But yeah, you absolutely can do that from using the identities. All right. Number 20, worksheet. It wants to know, find the area of the region in the first quadrant between the curve y equals e to the negative 2x and the x-axis. Okay, so y equals e to the negative 2x looks something like this. And they want only the first quadrant. So they just want this guy. But forever and ever and ever. Well, this thing, I didn't do a very good job drawing it, but it does keep getting closer and closer and closer. So that means, and we want the area. So what they're asking you for is you want the integral from 0 to infinity, since they just said first quadrant, you can start it at 0, of e to the negative 2x. Yeah. And that's an improper integral, so that means that it's equivalent to the limit as b, for some reason I like b's tonight, from 0 to b of e to the negative 2x dx, which is, you can evaluate that. Antiderivative of e to the negative 2x would be an e to the negative 2x, and then we would have multiplied by a negative 2 if we were taking the derivative, so you got to undo that. So it's a negative 1/2 e to the negative 2x, and from 0 to b. And so then this is equivalent to the negative 1/2 e to the negative 2 times infinity, right? Like negative infinity like that. Oh, crap. I should probably have plugged in a b. Hold on. Yeah, I like to cheat and not have my notation proper, which is really bad. Come on. Okay. I'm going to take the limit as b goes to positive infinity of negative 1/2 e to the negative 2b minus negative 1/2 e to the 0. Yeah. And so now as b goes to infinity, you're talking about a negative infinity, right? And so this ends up being a 0 plus 1/2, which ends up being a 1/2. Truly, wait, here's what you should be doing. I don't. Honestly, I plug in infinity, and I shouldn't. You're not really supposed to plug in infinity. But this graph looks like this, right? And as b is going to infinity, then your y value is getting closer and closer to 0. So that's why that guy zeroes out. And then 0 times -1/2 is still 0. So then, honestly, the way I think about it is this ends up being a -1/2 times e to the negative infinity, which means it's like a -1/2 to the infinity, right? Because it's e to the infinity, which is infinity, and 1/infinity is 0. So I don't know. That's just how I always thought about it. But okay, I caught up to you. What other questions do you guys have? On the worksheet. That's a good one. They want you to show that the natural log of x grows slower than the 4th root of x. Okay, remember, if I'm asking you to show slower, you need to show slower. You can't show that the 4th root of x, so I'm going to write it, don't show the other way around. Don't show that the 4th root of x is faster than natural log of x. Does that make sense? Like, we're testing on do you know how to say that the natural log of x is slower, and that's when you take the limits as b goes to, or as, is it x? Yeah, as x goes to infinity, and it ends up being 0, right? So don't flip it and show that the other one is faster, even though, yes, it'll work, but that's not what we're looking for. Okay, so to show that it's slower, we want to take the limit as x goes to infinity of the top guy needs to be the natural log of x, the bottom guy needs to be the 4th root of x. And this is definitely an infinity over infinity, which means you can do L'Hopital's rule. And that would be the limit as x goes to infinity of derivative of natural log is 1/x. Derivative of, how about if I rewrite this guy to make my life easier? 4th root of x is x to the 1/4. And so the derivative of x to the 1/4 would be a 1/4 x to the negative, because 1/4 minus 1 would be a -3/4. Rewrite this guy. This is what our comment on the PowerPoint and what's on the test was. Rewrite it, like you're going to do algebraic stuff, right? So here's what you don't go and try to figure out what this limit is when you have a fraction over a fraction. Simplify it. Do the algebraic simplification first and then figure out what the limit is. So this ends up being I don't know if you can tell this, like you got to know your algebra. This is the limit as x goes to infinity of 1/x over 1/4x to the positive 3/4, right? The 4 is in the bottom, and then also the -3/4 power says kicks it downstairs. So that means this is equivalent to the limit as x goes to infinity of, multiplying by the reciprocal, you'll have a 4x to the 3/4 over x. Yeah? And then those are the same base, and so you end up with the limit as x goes to infinity of a 4 on top. You'll end up with an x to the 1/4 on the bottom. So now when you plug in infinity, now it's very obvious that it's a 4 over an infinity, which is 0. And that's what you need to do to show that it's slower. So therefore, natural log of x is grows slower than fourth root of x. All right, that was 15. Number 10. We've got the limit as theta goes to pi over 6 of 1 plus cosine of 6 theta over 1 minus sine of 3 theta. Okay, so when you try to plug in a pi over 6, this ends up being a 1 minus cosine of pi, so it's a plus negative 1, and then a 1 minus sine of 3 pi over 6 is pi over 2, so that's a 1. So it ends up being a 0 over 0. You do need to confirm that before you use L'Hopital. You can't just go using L'Hopital willy-nilly. You can only use it on like a 0 over 0 or infinity over infinity and stuff. So, but once you show that, then you're like, okay, I can apply L'Hopital's rule. You need to use the limit notation on every step. I know it's a pain, but you do. Taking the derivative of the top, it'll be a 0, and then plus derivative of cosine is negative sine. So we have a negative sine of 6 theta. Chain rule says times 6. And then derivative of the bottom would be a derivative of 1 is 0, and then a negative derivative of cosine is positive cosine of 3 theta, but then chain rule would say times 3. All right, so when we plug in pi over 6 now, you would have a sine of pi, which is 0, and a cosine of pi over 2, which is also 0. So you got to do L'Hopital again. And we got the limit as theta goes to pi over 6 of, you could simplify this, so it would make it easier on yourself, but whatever, or you can leave it. You got a negative 6 there, and then times the derivative of sine of 6 theta would be, derivative of sine is cosine, but then you would have went times 6, and then I've got a negative 3 times, derivative of cosine is a negative sine, the chain rule would say times 3, and so what does that end up being? That ends up being the limit as theta goes to pi over 6 of negative 36 cosine of 6 theta, I don't know why I'm rewriting this, over negative 9 sine of 3 theta. So that ends up being a 4 there. Can I plug in a pi over 6 now? Let's see. We got negative 36 times cosine of pi is a negative 1, and then a negative 9 times sine of 3 pi over 6 is 1. And so you end up with a positive 36 divided by negative 9, which is a negative 4. Nope, I made a mistake somewhere. No. Positive 9 for defractor. That's positive. Negative times a negative, so that's a positive, and so it's 4. All right, so that was 10 from the worksheet. Will there be inverse trig functions on the test? I would count on it. Those are fair game because the AP exam will ask you for it. So yes, I would definitely know the, it's not all of them, it's the 3. It's inverse sine, inverse cosine, and inverse tangent. Those are the ones I would know. If you see something over 1 plus x squared, that's inverse tangent. And if you see something over the square root of 1 minus x squared, that's inverse sine. And the reason why cosine is fair game also is because it's just the opposite in sign of the sine one. So -1 over, you already have the 1 memorized, so it's not that hard to, that's inverse cosine. So those are the ones I would definitely know for sure because they'll show up on the AP exam. And so yes, we put them on there. Yeah, all the integration techniques are fair game. Tabular, integration by parts, all kinds of stuff. What else? Sure. Number 7 on the quiz. That's a good one too. All right, so they want you to determine the indeterminate form and then also evaluate it. Do you see that this is a function to the power of x, right? It's a function of x and then to the power of x. So that's how I know I'm going to end up having to use the natural logs. It does want me to identify the form though. So when you plug in a 0, you would have a 1 plus 1 over 0 to the 0 power, which this is a 1, and then an infinity, which you take infinity and you add a 1 to it and it's still infinity. So the indeterminate form that you're going to identify here is infinity to the 0 power. And then, because it's a function of x to the power of x, that's when you use L'Hopital, or I'm sorry, logarithmic. I feel like, did you see other kinds too? Like, it's a function of x to the power of a function of x, right? That's when you know you're going to use logarithmic. So I'm going to let f of x be my 1 plus 1 over x to the x so that I can take the natural log of both sides. And I do that so that I can take this x and go whoop, bring it around front like that. So that this ends up becoming an x times the natural log of 1 plus 1 over x. And so I'm still going to have an issue when I take the limit as x goes to 0. I'm still going to have a 0 times, what would that be? A 0 times infinity. Yeah. This is a 0. Well, I should say taking the limit, right? We're going to take the limit as x goes to 0 from the right. It ends up being a 0 and then times the natural log of infinity, which is an infinity. Yeah. So I'm going to rewrite it as a division so that I can then use L'Hopital. I would write it as the natural log of 1 plus 1 over x and then divided by 1 over x. Dividing by the reciprocal will get it done. So now I have a natural log of infinity is infinity, and 1 over 0 is also infinity. So now I have an infinity divided by infinity, and I can do L'Hopital. So I'm going to go to the next page. So I'm going to do L'Hopital. And I'm going to do it on the next page. I'm not going to rewrite it again. Yeah. So doing L'Hopital, I'm going to take the limit as x goes to 0, and from the right, And I'm going to take the derivative of the natural log. What would it be? Natural log of 1 plus 1 over x, which will be a 1 over what you were taking the natural log of, so a 1 plus 1 over x. But then chain rule says go inside of there and take the derivative of the inside, which would be a 0 plus a negative 1 over x squared. That was just the top. Derivative of 1 over x is a negative 1 over x squared. And then because this is multiplying and, 0, just you can ignore that. These two guys end up canceling out. Oh, that's so nice. I love it. Do some algebra, right? Don't go plugging 0 in yet. You should not have a fraction over a fraction. Don't you dare take the limit when you've got fractions inside of fractions. Simplify them first and then take the limit. So this is equal to limit as x goes to 0 from the right. And I'm going to simplify this guy, right? So I've got a 1 over, if I get a common denominator here, this would be like an x over x plus 1 over x, right? So that it's, I know this is a pain. You'd always go off to the side to simplify and then plug it in. But it's a 1 over x plus 1 over x. And a 1 over means take the reciprocal of the whole thing. And so it's a x over x plus 1. Can I plug a 0 in now? Yes, you can. When you plug a 0 in now, you get a 0 over 0 plus 1, which is 0 over 1. And when you have 0 on top and a number on the bottom, that is 0. But remember at the very beginning, this wasn't our answer. We had taken the natural log of both sides, and so it's really that it was the natural log of f of x was equal to this limit and blah, 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 so it was equal to 0. And so what I'm going to do now is take e to the power of and e to the power of so that I've got f of x, because remember e to the power of the natural log cancels out. You're just left with f of x. It's e to the 0, which of course is just 1. So the answer was 1. Anything else? I'm not seeing anything on my list of what's going to be on there that we didn't go over. Wow, we didn't go over how you find sequences. Let me at least give you that. You're welcome, because we only have a couple more minutes anyway. So don't forget sequences. How do you find it? I know this is an Algebra 2 topic, but so these should be give me points, right? If it's an arithmetic sequence, how you find the general term is it's the first term plus n minus 1 times the common difference. Remember, arithmetic means that you're adding the same number to get to the next guy. This is what we call the explicit form. If we ask you for the recursive form, you have to identify, so that's explicit. Okay, then for the recursive, I should have organized this better, but whatever. For the recursive way, you have to identify what your first term is. Your first term is something, and then you'll say the nth term is the term right before it, and then plus the common difference, and you also need to say for n is greater than or equal to 2. So explicit for arithmetic, recursive for arithmetic. Yeah, and then geometric, you've got an is equal, so any term, the nth term is the first term times common ratio raised to the n minus 1 power. That's the explicit version. You can cuss it out and really make it an explicit version. I know you want to. And then recursive would be, you say, A1 is some number. You have to identify. You won't get full credit if you don't identify the first term. And then you say the nth term is the first term, or the term right before it, I mean, n minus 1, and then times that common ratio. And that's for n is greater than or equal to 2. So this whole thing was the recursive, and this whole part is the recursive way. And yeah, I feel like we went over all of the concepts and everything that you're going to see. I don't think that, like concepts, right? Derivatives of trig functions are fair game. Derivatives of inverse trig functions, fair game. Showing that a function grows faster, showing a function grows slower, showing that it grows at the same rate. All of those. Improper integrals, we did all kinds of those. Yeah. L'Hopital we did a ton of. I think that's it, guys. I think we did it. Y'all asked really good questions. So, I think it's time, right? You want past time? A little bit. All right. Okay. You have an amazing day too. I will see you tomorrow. Stop this. I'll post this recording.